Hi everyone, welcome back to my YouTube channel. This is HMGM, How to Model a Gold Mill in 27,000 Easy Steps. Today we're finally getting back on another build episode, and it's been a while, I know. What we finally want to do, now that we have the mill foundation mostly sorted, is build on top of it the foundation blocks on which various pieces of equipment were constructed. Quick preview of what's going on down here. Up here on the top level, we have everything that holds up the ball mill, the rate classifier. Down here we've got the actual main flotation stages. There were 4 cells total and a shaker table next to them. But in addition to that, you can see there's been a couple more items added into the floor. There's a couple floor drains we had missed, and the way we found that out is recently we had a chance to go back up to the Santiago Mill, and contrary to expectations, we found that it was open, even though some additional maintenance had already obviously been done on it to secure one of the outbuildings against further weathering and damage, and the Forest Service signage wasn't being maintained. So we took a chance on getting a couple of photos to see if we were still up to snuff on our dimensions and measurements, and lo and behold, there's some floor drains we'd missed. So we went ahead and put those in, and you'll get to see more of those in today's episode also. Okay, in order to construct things, we're going to use the same procedure that we used on the main part of the mill itself. We're going to build the base layers out of wood and try and make it reasonably rigid. Those are going to have 60 grit sandpaper glued on with spray adhesive, 3M Super 77 or Gorilla, something similar to that. And that will provide a gripping surface for us to apply commonly available finishing products for repairing sidewalks and patching floors and things like that. You can get those in almost any home improvement store, and if you know how to work with them, they will turn out very convincingly looking like a block of concrete. We got pieces of poplar board. You can buy this in home improvement stores. It's usually somewhere over near the front of the lumber section. And I like it because it's soft, it's easy to work with, you can make fun little shapes out of it, and it doesn't take a lot of cutting effort, and it glues together pretty nicely. It sands very easily if you need to shape and modify. Sometimes at home improvement stores, and then very definitely at places, like hobby stores, Hobby Lobby, Michael's, like that in the US, or whatever you've got wherever you live. Also at Ace Hardware, I discovered there's these basswood sheets. Now this is not balsa wood, it is basswood. It is thicker and denser than balsa wood. You can't just crush it by squeezing it with your finger, but it's very soft and you can cut it with a hobby knife. So this I found was really useful. Some of these pieces will be useful, I believe, when we actually do our framing and siding of the main mill structure itself. But today, we're going to be working with these to create foundation blocks. Let's see what happens. Planning is everything, and to get this moving, we reopened our AutoCAD model from way back when, fiddled with layers, and then ran off a few prints of the foundation layout. Back in the model again, we pulled dimensions off the equipment foundations and their positions relative to the floor edges, sketching these down as we went. Some might use a spreadsheet for tallying these things, but A few calculations were needed to convert our CAD model, drawn in real-world feet, to our physical model, which is sized at 0.6 inches equals 1 foot 0 in real life. That got us to floor plan drawings with the base footprint of each block we needed to build. Since these also have heights, those were also pulled from the CAD model, and finally, we rough sketched each block in 3D to act as a build guide. Now that we had all needed data from the CAD model, it was time to put away the stuffy digital tools and switch to different tools that would give more satisfaction. starting to get somewhere. It's almost looking a bit like a SolidWorks model before some of the textures are applied, but there we go. Those should be all of the major equipment foundations that need to be rendered in concrete. Starting right here, these two support the ball mill. This here supports the ball mill's drive motor, and that there will support the main pulley. Coming out here, we'll have a rate classifier. Down here, these are the foundations on which the flotation stage will rest. And over here, these four small cubicle foundations are the mounting points for the Wilfley style shaker table. So there you go. What I'm going to have to do next is put these little guys up on little stands so that I can separately apply finish and paint them. And then I'll come back, install them on the foundation, and then just seal them around the base. That way I don't ruin the paint job and effects I already have going here. Once that's done, I'll be able to start doing equipment models and timber framing. The foundation blocks needed to withstand a lot of finishing work, so after some careful thought, we decided to temporarily mount them on a scrap sheet of 1/4 inch plywood. Each block was mounted on the plywood with enough clearance to operate tools such as a putty spreader and a sanding pad. A bit of double stick tape film was used for temporary adhesion, and then small wire nails completed the assembly. These could be pulled out later to release the blocks from the sheet. The finishing materials included floor patching and leveling compound and a bottle of concrete crack repair caulk. Both are very spreadable and contain sand for texture. They mimic a concrete finish, but are actually acrylic based. That meant easy water cleanup during finishing. Also, both are sandable after they cure, and that allowed us to reduce the excessive surface relief. In scale, the finished product would resemble 1930s era finished concrete. To save on the weathering effects added later, the foundation blocks were pre-dusted with light sprays of tan and gray spray paint colors. These are intentionally subtle, but do remove the bright light gray color of freshly finished concrete. At this point, we needed to transfer the foundation footprints to the actual model. We measured and penciled everything in the old-fashioned way. Since a carpenter's pencil leaves lines somewhere between 1 and 3 inches wide at real-life scale, we developed doubts about a couple of our foundation positions and went back to the CAD model for a recheck. Once those questions were satisfied, everything else landed where it was expected. Each piece was then removed from the temporary plywood, cleaned with more sanding, and then placed over the pattern locations for a final visual check. Then it was ready for the point of no return. Holes were drilled for future support screws, but for now, we glued everything down using high-strength construction adhesive. Second level was weighted down for curing and left for a few hours. We then came back and finished the top level in the same fashion. Okay, what I'm doing now is spreading the Quikrete concrete patch repair around the bases of the foundations. This is mimicking what would have been done originally. They would have grouted around the bottoms of these to prevent water from working its way under and undermining the foundations down there. Kind of interesting to think about the people originally building this thing at full size. It was completed in 1935, according to the Forest Service sign that's up by the gate. For context, I had to go look it up, but in New York, the Empire State Building was constructed from 1930 to 1931. And on the West Coast, the Golden Gate Bridge in San Francisco, they started constructing that in 1933 and finished it in 1937. So this was built kind of in the middle of all that. That was an era when iron, steel, concrete, all that kind of material was at the forefront of technology. Still, it's pretty impressive that they managed to haul this much concrete way up into the mountains back then and build this thing as well as it is. And now the part where we rip up our previous work to add more missing features. As mentioned earlier, our latest visit to the Santiago revealed floor drains that were missing from our model plans. One of these is a basin structure and sits at the base of the rake classifier. It would catch splashes and leaks from the ball mill discharge and the classifier discharge. We didn't get exact dimensions, but based on photos, we decided it roughly spans the area below the classifier's lower support foundation. Interestingly, it simply discharges to the next floor level below. We had to cut this one deep enough to go through some of the base structure, so an additional plate was added on the bottom side. The next missing bit was a collection drain for the level hosting the flotation cells and shaker table. This drain is simply a funnel of sorts to bring all wastewater from the level into a discharge trough on the next level below for final disposal from the mill. There's an additional floor channel drain on that bottom level, but we haven't gotten that one retrofitted yet. So there's nothing to show today. The double-edged sword of getting better data midway through a project is that you can be more precise going forward, but you might have to go back and rework something you thought was finished. When reviewing the area around the flotation cells, something jumped out at us, and that was how short the mill's foundation supports appeared compared to the ones we had built. On our model, they rise a bit past the halfway point on the adjacent wall. But in the mill, it's more like 1/3. We were fairly sure we had the top of the flotation cell scaled correctly, so what's going on? The answer is in all this cross-stacked lumber, or cribbing, which we had previously overlooked. Turning back to the CAD model, we only have one layer of lumber, but in the real world it's 4 layers of varying thicknesses. We decided our foundations were about 18 to 24 inches too tall in real life scale, or more like an inch at the model scale. Since each foundation block in real life has an 8x8 or possibly 12x12 lumber top cap, we decided to first cut down each foundation by the equivalent of around 8 to 10 real-world inches of the full 20-ish required. Next, we scored an additional 8 to 10 inch equivalent segment all the way around through the sandpaper layer, and then peeled that off to remove only the top finish from the wood underneath. The surface finish of the concrete was then restored around that score line to give the effect of a shorter concrete foundation with a lumber top cap already installed. Hey everyone, thanks for joining me again for HMGM, another episode of How to Model a Gold Mill in 27,000 Easy Steps, featuring a long overdue build episode. Hopefully you enjoyed seeing all that. We kind of gave you a teaser of what's coming next because when we panned over the foundation there at the very end, you could probably see some gravel and rocks and ball mill media kind of scattered around with a lot of weathering effects towards the top there. We intend to do a lot more of that. We want to kind of fill all that in as the next step so that we don't have framework of the building or the deck around the flotation mill and things like that in the way while we work. So we'll try and get a lot of those small details put in, especially along with some of the pipes and plumbing that are up against the walls too. But that's coming up later. Some of the work you saw today actually started a couple years ago, the building of the foundations on the temporary plywood sheet, and then we got interrupted to do the support structure, which we covered in our last build episode. So check that out if you haven't seen it yet. In the meantime, we'll probably be doing a couple more Mill Explorers or technical episodes in between. But in any case, hope to see you again next time.
Has anyone seen my phone?